right, so we're going to be presenting on neural interfaces for our emerging technology projects. My name is Alexander Gonzalez. I'm a biomedical engineering major, and in the future, I hope to go into research and development for medical devices.
My name is Tyler Campbell. I'm a health science major, and I'm looking to go into the dental field.
My name is Jessica Liu, and I'm hoping to go into the medical field.
So the first thing we're going to open with for our presentation to kind of make it interesting is this program called Mentimeter, and it's going to allow us to make like a word bubble. So in the middle would be the word neural interfaces, and people will be able to kind of log into this website and live add words that they associate with neural interfaces, and it'll make like a word map. So that's kind of something we're incorporating to make our presentation a little interesting. We're going to jump into what are neural interfaces at a very general scale. So we're going to have a definition, talk about how they vary a lot. And I think the big thing we want to emphasize is, yes, neural interfaces have been existing for a long time, but only in laboratory settings for like a very small amount of people. But the interesting thing about what we're talking about is we're approaching it becoming bigger and commercialized and available to more people. Um, and then this is like a short clip that kind of talks about neural interface technology as a whole. And you'll see like a lot of this technology, yes, it's really cool and they've been doing it for a long time, but it's just not available publicly.
So for this slide, this is just like another fun thing that we're going to mention. So it's like Marvel references that they kind of use like brain implants or for Professor X. He uses like in the movie like a machine and it's called Cerebro, and he like enhances his telepathic powers through like amplifying his brainwaves. And for Doc Ock, he like attaches like mechanical arms to his body, and he connects the arms to his brain through like a neural network. But then in like the movie, like the inhibitor chip like breaks and it like takes over his body. So we could mention like the downsides of neural implants and stuff like that as well. And then we're also going to talk about the difference between BCIs and neuroprosthetics. So brain-computer interfaces connect with the brain through a computer to do like certain functions, while on the other hand, the prosthetics they connect the brain to like devices directly. So an example of that would be like a prosthetic limb. And then we're going to talk about basically how they work. So all devices can be slightly different. And then we listed out how they work in general. So the first thing is acquiring brain signals. The second thing is analyzing the signals. The third thing is converting the signals into commands. And the fourth thing is utilizing output devices to perform desired tasks from these commands. And then we'll talk about like the main overarching goal of BCIs. And right here, we put that they can replace or restore useful functions to people with disabilities. And then later on in the presentation, we're going to talk about some specific disabilities that these BCIs can help people with. And this is just a short clip on neural interfaces and basically just like a informational video that's helpful to visualize. This is just like one of the fun little activity things that we're going to include in our presentation. It's basically just a trivia question, and we're just gonna like send out a thing that people can join and then just answer the question.
And then we're going to mention different companies that are currently working on these novel interfaces. So first we have Synchrone, and they are doing neuroprosthetics and implantation procedures. So basically they allow their patients to interact with a computer using their own brain signals. and that we're just going to go over information on how the implantation is through the blood vessels of the brain as opposed to open brain surgery, so it's less invasive. And they're addressing neuromodulation and neurodiagnostics and how they completed their first human trials. And then this is just a video of how they're implanting it. And then this shows how it's impacting someone with ALS beforehand and how it helped them. And so now we're going to look at the opposite side of these companies and how they help people without health conditions. And then we would go into Neuralink, and we'll create the distinction that Neuralink is a brain-computer interface, while Synchron is neuroprosthetics.